All right, so welcome to this talk. AI is coming. Now what? We had the panel this morning, which was really interesting, and I'm going to kind of push into it some more, maybe a little bit deeper down the AI rabbit hole here, and kind of looking for where are we going? How do we architect ourselves out of this? So, trying to architect the future of software. So it was really interesting last year. I speak at conferences all the time, and I watched kind of the wave of realization cross our space, the IT space. From the beginning of the year, most people were blissfully ignorant of what was going on, and in later parts of the year, more and more people seem to have realization that, hey, this AI thing is kind of big. So last year was crazy, but it all started at the end of November in 22 when OpenAI released ChatGPT on the world. And this is really interesting though, because AI has actually had a very long history, and I don't know how many of you are aware, but there was actually what they called an AI winner. This was back in the 90s, and that era. I've been around for a while, and I actually went to a conference in Miami a long time ago, and there was a lot of excitement and everything, but it just completely died out, and it lost momentum. The other thing, though, that's also really interesting is that, and I've been reading some books about this lately, is that the neural networks fell on very, very hard times back in that. You couldn't publish a paper where even mention the word neural network, or the words neural networks, and that was like death to the paper. Now they're changing the world. I'm going to really kind of push into that one as well. So OpenAI let it out. I mean, there's a lot of things going on, and we're just getting started. I mean, I don't know about you guys, but I follow a lot of people on YouTube on what's going on, and they're actually apologizing now. It's like, I know I said this last week, but this week has been another crazy week of announcement. It's this continuous flow of innovation that's occurring at an incredible pace, and we're definitely riding the exponential curve here. But for us, for the first time, I think in software, in 70 years of the history of software development or more, we know things are changing. And I love this picture. All my pictures are from AI in this, but I love how this picture came out, because this is the way I feel. It's like a lot of my skills and expertise and knowledge and experiences, it just seems to be evaporating, blowing away. I mean, things are just crazy. And what's really happening is we're on the edge of the end of an era. I think all of us are going to remember that we were here when this happened in the beginning of the 20s, in the 21st century, that this AI thing came on. We don't have a clue what the future is going to bring. There's all kinds of speculation, but there's also a pretty universal realization that it's very, very hard to predict what the future is going to bring for us here. But we are at this inflection point, and I think it's an inflection point that will impact all of humanity, but it's certainly going to impact us as well, in one way or another. And I think it's already big, but I think it's going to be even bigger. So you will remember this time, mark my words. So there's this, like I said, I've been following it. I picked up on what was going on about maybe late January in 23 or early February, that ChatGPT had come out, and I just was infatuated with it, and I just kind of really got into it pretty quickly. And so I've been watching all these things, but I had this weird feeling, like we are at this end of an era, and it's like, okay, on the one hand, I'm feeling, oh man, what's this going to do for me? I love software development. I've been doing software development a long time. This is my it's my passion, and I get paid well for it. Is it going to impact that? But I'm also an optimist, so I had a degree of hope. But there was this weird feeling. So one guy in particular I've been following on YouTube came up with a name for this feeling. And when I watched the video, it's like, okay, yeah, this is it. So he actually gave it a name. He calls it Vesperance. And these two QR codes are for two of his videos. The guy's name is David Shapiro. Maybe some of you follow him on YouTube. He's pretty interesting, but there's a lot of really good resources, especially on YouTube, about what's going on in the AI space and so on. But he had this name for it, and that's what I was feeling. It's like this weird feeling of Okay, what's going on? How is this going to impact me? And hope as well. But like I said, I'm an optimist. I don't want to be a downer here. I want to kind of leave this, I think there's good things coming. Let me say it. You may hate me in the future when he's all that jerk. He told me with good things coming, and here we are under the fist of a artificial superintelligence that just makes our lives miserable. But it's not just about the machines. It's about us. How do we take advantage of this? That's where the real opportunity, I think, is at. So in this talk, I'm going to cover, it's in 3 parts. I'm going on a limb on 2 of them. The first one is kind of an idea of developing software that I like to play with the term Micromine. So I'll give you a little introduction to that. And the second part is the future is now AI coding assistants, and there's a lot happening here. Some things that developed just recently that are really interesting. And then I'm going to go way out on the limb. This is like my future crystal ball, for predicting the future. And I'm going to kind of push into what programming may look like. We kind of heard about some predictions this morning in the panel, which was great. But I'm going to maybe kind of propose a plan B, another path. So you'll see when we get there. So this Micromine idea, what is it? So it's not about AI and machine learning. One point I want to make, because I think it's really interesting, is that the kind of software that's being developed to drive these AI systems is so fundamentally different than the way I've written software for 48 years. I've been a professional software developer for a long time. Nothing like it. Nothing, so if you're not writing, that kind of code, it's a completely different league than the code most of us, I think, have been writing. If you're a professional software developer, have been writing, it's totally different. But I'm going to show you some things that parallel this that is more familiar in our territory. But it's not AI and ML. It is based on an event-driven and what I call pure event-driven, and I'll describe that pretty quickly. And I'll connect it to where I'm going here in the AI space. So bear with me for a few minutes. So this is an example of a demo application that I wrote. I like to, like I said, I've been writing software for a long time, been writing back-end production systems for a long time. So now I'm a developer advocate, so I don't have to write production systems anymore. I get to write fun demo systems, but I like to have demo systems that are actually kind of interesting. So this one is an application, but it's written in this event-driven type of form. And the design diagram, this is a real design diagram. It's not a pretty picture. It's a real design diagram. And what I'm trying to do here is show the behavior of an event-driven system. So like these diagonal boxes represent very small, very focused services. And when they light up, they've received a command to perform some, request to perform some kind of an operation. So the commands come in through the top, the events come out through the bottom. And you can see, like in this here, there's a line going from one of these services to another service. And that triggers that service to get a command. It emits events, and it cascades. So what's happening here, this is an event flow. This is an event-driven type of a system. The behavior of this system is driven by the flow of events. This is a real flow in this application. In the implementation, I use this as I'm running the software to guide me through my design. So it's not, there's kind of a hybrid form of event-driven, and there's this pure event-driven. This is more what I call, I like to refer to as pure event-driven. You're all in on events. So anyways, what blows my mind about this, and I've been playing with this for about a year now, is that there's only 3 software components here. There's these little diagonal boxes, which are these, like I said, they're these very small, very focused services. There's views, these V-shaped things, and there was a talk yesterday talking about CQRS, command query responsibility segregation. This is what's going on here. It's just command query responsibility segregation, where the writing's happening in the service and the reading or the query is happening in the view, and they're separated from each other. So those are the 2 components. The third component that's also really interesting is the action, and the action is the thing that subscribes to the event stream coming from one service and sends events, or actually transforms events into commands to go to downstream services. So this whole system is built just using these three relatively simple software patterns. Now here's where I go. Some people have said, okay, Hugh, you're going on a bridge too far. I don't care. I like going on a bridge too far. I like pushing out. So like I said, I'm really curious. I've been very curious for a long time about neural networks and the working of our biological neural networks and things like that. And as I was getting more into this software pattern, I was thinking, wait a minute, there's signals coming in and there's signals coming out. And that's basically the mechanics of a neuron. And then the action is kind of the synapse. The synapse is the connection between the signal coming, the nerve signal coming out of one neuron and the signal going into another one. By the way, in our biological neural networks, the computer between your ears, there's roughly 86 billion neurons. That's the number I keep hearing, 86 billion. Most neurons connect to about 10,000 other neurons. So this is massive. So there's trillions of connections in your brain. So you have the most powerful computer on the planet between your ears, right? It's powered by not vast amounts of electrical power. You eat an apple and your brain's good to go for the rest of the day, or for the morning, that type of thing. So it's an incredible machine. So anyways, this is the way the system works. It's just this cascading event flow that occurs to make things happen. So that's a real quick introduction to this Micromine thing. So I want to show you this thing in action, though, because I want to show you it from a different perspective. So this is a little movie I did where I ran the demo, and I grabbed the logs, and it's projecting the activity of the application in this kind of three-dimensional space. So you'll see that they'll kind of form themselves into like circular regions. So this is this demo system processing 200 orders. This real activity from the logs. The color of the dots, like the red dots, represent orders that have come in, but there's insufficient stock. The green dots are the orders that have gotten stock. The yellow ones are waiting, waiting to be processed. On the right is stock. So you can see stock flowing into the system. So what's happening here is that this little application is taking in orders, it's allocating stock to the orders. The stock, it knows for every single physical unit of stock goes in this system. Not only that, it has behavior of handling back orders. So it detects that orders came in, there was insufficient stock. It triggered stock to come in. When the stock comes in, it goes hunting for back orders. So and that's just some of the behavior of this application. There's only 13 of these entities in this system. And all this fairly interesting behavior came out of it. And it kind of blows my mind. The code in each one of these different little services is relatively simple. The interesting behavior comes out of the patterns of flow, the processing patterns of flow that are in this system. So let me stop this. So anyways, I wanted to kind of show it in a different perspective. So every dot is an instance of state. Every line was an event that triggered a command. So and that's real. It was real data that did the video. So this is what's kind of blowing my mind. Is this kind of processing flow is, I'm kind of thinking, wait, this is biologically inspired event-driven processing flows. Where you have units of computation that have similar functionality. There's a lot more going on in biological neural networks. There's certainly a lot going on in artificial neural networks as well. But here, at the simple fundamental level, just mimicking, in a very simple way, this kind of behavior of a neuron, you get this pretty interesting power with these event-driven processing flows. So this is what's crazy. With a biological neuron, signals come in, and there's great videos, by the way, on this. If you're interested, you just search YouTube and you can find some really good visual videos on this. And signals come out. That's how we're conscious. This is how our brains work. This is how, when biological neural networks appeared on the Earth, we took over the world, right? Now artificial neural networks are appearing, and the saga continues. But what gets me is that with this kind of elegant simplicity, you get this profound cognitive complexity and it's really stunningly powerful capabilities in our brains, in the artificial neural networks. But what I'm trying to say here to us is that you kind of can get it at our level in the way we write software. The software that I'm writing here is relatively familiar to anybody that's done any kind of programming. So just real quick, the flow is, because this often doesn't get covered, I think, enough when people talk about event-driven. They seem to be somewhat ambiguous, but to me, it's very precise. A command comes in, that triggers the creation of events first. The command is based on the current state of the thing that received the command, and the contents of the command. The computation is what events should be triggered as a result of this command in the current state. So the result could be no events, one event, or multiple events could come out. The events go through the synapse, this function called an action, and they're transformed into commands. So like order checked out is the event, create order is the command. So there's this, this connection. There's this flow from events to commands and commands to events. Events to commands, commands to events. And that's what's happening here. Order gets created, order created event. Events are usually termed in past tense because events are things that have happened. Commands are requests to perform things that haven't happened yet. But there's a nice symmetry to the whole flow. The other thing, like I said, these entities are simple. They're basically, I like to think of them as distributed, durable objects. And I'm just showing it, like a shopping cart. That's it. It's not a complex transaction. It's not a multi-table thing. This is very focused, very limited for good reasons. So how does this figure in the age of AI computing? Well, the first thing, and I've already mentioned this, is that it's kind of mimicking or modeling itself after what seems to be a very successful computing pattern. The biological neural networks of our, that work in our brains, and then the AI neural networks as well. So it's kind of leveraging off of that. But to get a little bit more practical, this code lends itself well to the tools that are emerging, the AI tools, and I'll get into that in part 2. So I'm starting to see that I'm writing code in a way because there's a nice structure to it, and I'm starting to write code where I'm thinking ahead of how is the AI going to interpret my initial code so we can together build the code out to its completed state. So in a way, I'm starting to think of code as a prompt. But these AI assistants love these reusable code patterns. There's lots of reusable code patterns. Like just this example here, this is just the API of one of these entities, the thing that accepts commands. It's using string annotations for the APIs, but you can see there's 3 APIs here, and they all follow basically the same pattern, right? The AIs love this stuff, and I'll show you that in a moment. But for humans, for us, how do we play in this game? We're really good at having the big picture. We're also really good at kind of the high-level design patterns. So how do you compose an application in detail? Imagine. You can't go to an AI and give it a 5-word prompt and expect it to build you a full enterprise system, right? That's crazy. There's a lot of detail that goes into a full enterprise system. So it's going to take more work than, give me an HR system. Let me know when you're done. It's like, no, it ain't going to happen. It's going to be, what do you mean by the HR system? There's a lot of detail there. Somebody's going to have to deal with that. We're really good at having that big context, at least for now. And I think maybe for a while. But we're also really good at patterns as well, reusable design patterns. So I want to show you a little bit of that here, which really also surprised me that I'd never seen this before in some of the software I worked in the past. There's a saga pattern. That's the classic saga pattern. I didn't know this until I got into it when I started doing this stuff, that there's actually 2 forms of the saga pattern. And whenever I mention it, everybody, oh yeah, I know. It's like, nobody told me. But there's a choreography saga pattern. The more common one is called an orchestration saga pattern. Orchestration saga patterns a workflow. Do step one successful, do step two successful, do step three fails, undo step two, and then undo step one, that kind of thing. That's kind of an orchestration saga pattern. Most of us like that. I actually am getting to like this choreography saga pattern. And this is what I showed you, the design flow, the flow of a sequence of events is a choreography. There's no controller. It's just event streams feed event, commands feed event streams, and the behavior of this whole system. 13 entities taking in orders, allocating stock, handling back orders, ordering stock, detecting stock that's low. I haven't done this yet, but you can even have some learning behavior where you could easily tweak some of these things so that it learns how to better order stock to prevent back orders from occurring, for example. That's within the realm of the capability of the system at this level. Not getting into all the GPU kind of computing, just relatively simple basic programming that we've been doing for a long time. Another pattern is one-to-many, meaning one event fans out to multiple other instances of entities. There's 25 of these actions in this system, and 5 of them follow this pattern. I call it this generation loop. An event loops back on itself to keep the thing doing some work until the work is done. Of the 13 entities, there's 2 that have this generation loop pattern. This one blows me away. This is a little bit more complicated. I just don't have enough time to go into it here. But I'd be happy to talk to you after the talk. But at the third, I call it a reduction tree, and it is a tree structure. The leaves of the tree have detailed information that are coming in as events and commands, and that detailed information is being reduced down the layers of a tree so the trunk is just like summing up. Like this is counting inventory or monitoring back orders and things like that. Of the 13 of the entities in the system, 4 of them use this reduction tree pattern. So, there are other patterns, but the main point is that there are these patterns, and I feel like the whole process of design is way more fun, but it's also way simpler. I have these patterns that I can use to design the system. So when I'm thinking through the design of the system, I'm thinking at kind of that level of the diagram. How do things flow through the system, and it feels more disciplined. So here I want to show you, this demo is called Earthship because the UI is a map of the Earth. You can zoom into any place on the Earth, and you can say, all right, generate 200 orders or 2,000 orders or 20,000 orders at this place, and it'll generate a bunch of random orders just to put some load on the system and show this thing, doing some real work. But this other application I call Transactor, when I've just flipped back and forth, this is what I mean about the patterns. There's the same processing flow, reduction trees are in there, one-to-manys, generation loops, all these different things that seem to emerge quite naturally from getting into the design process at using this type of an approach are applicable to this transactor. One area I want to kind of highlight is here and here, and I'm going to zoom in. So this is probably most interesting and maybe head-banging part of the system, is that this is the place where I call it transitive transaction. I made up these words, so blame me for the bad names. But what's happening here is that orders are coming in and they're acquiring stock. But it's not done as a single database transaction. It's done as a series of events, cascading sequences of events. So like this order item, red leaf or whatever it is, it gets created and say, I'm hungry, I need stock. So it basically just emits an event that says that triggers some behavior in the system to go hunting for available stock in a view, which is down in the bottom there. And if there is available stock, it will send a command to the stock order saying, hey, I got an order that's hungry for some stock. Are you available? So they go through this mutually agreeable series of state changes and ultimately end up in performing this transitive transaction. First A, then B, then back to A, and we got stuck. On the other side, it's a similar flow. You've got withdrawals that want to consume deposits. So that's what kind of blew me away. Once I figured out how to write this, because nobody was helping me with this, I was doing early days of this, and I'll tell you what this is at the end of the talk. But then the same pattern was applied on withdrawals consuming stock. Withdrawals consuming deposits. But it doesn't end there. Back orders. And the reason I wanted back orders is I like to build my own PCs, and this was back during COVID and the crypto stuff, and I couldn't get a GPU. And the darn systems that I could order GPU from didn't have like a back order thing. You know, they wanted you to sit there and click, you know, to try, when some GPUs just showed up, you try and get into it. And it's like, what a bunch of idiots. They can't write a system where I say, I'd like to buy a GPU. Let me place a request to buy a GPU. And so when the GPU comes in, send me one. I'll pay you. No, they wouldn't do that. So I wanted to have a system that handled back orders automatically. So there's a symmetry here. There's a reverse flow. When stock comes into the system, it goes hunting for back orders. When deposits come into the system, they go hunting for withdrawals that are pending that didn't have sufficient money to do the withdrawal. So there's this kind of symmetrical flow that happens as well. With these two little entities and a little bit of processing, event-driven kind of processing flow. It's crazy. So I just feel like the work I've been doing, because my company is about building high-end systems that can't break, that you have to run. So durability, scalability, all these types of things are really important to us. So this is why we're doing it this way. But it's also like with microservices, for example. I've been talking about microservice like a lot of speakers and people have been doing since they've come out. And it's like best practice for building microservices. And one thing, it's like, well, how big should my microservice be? Well, do one thing and do it well. Okay, well, now I'll do 2, now maybe 5, maybe 10. I've talked to some people at conferences like, we have these microservices that are so big, everybody's afraid to touch them. It's like, dude, you don't have a microservice. You got a monolith. You got a monolith here. You might be calling it a microservice, but it's a monolith, that type of thing. But anyways, this is really do one thing and do it well. These things they talk to each other asynchronously. We've been telling people to do microservice systems like this. They're loosely coupled. Loose coupling is extremely important. Processing occurs across state and time. What I mean by that is that each one of these services doesn't know anything about the rest of the system. All they know is commands come in. They don't care where the command came from. They're just responding to a command, and they emit events, and they don't care who consumes those events. That's the behavior of the system. So they're loosely coupled, which means they can run across a distributed system, no problem. A consumer of events from a producer can be down, and the producer doesn't care. The producer keeps running and it doesn't bother that the consumers are down. When the consumers come back up, they pick up where they left off, and they continue consuming. All right, so moving on. The future is now. AI coding assistants is part 2. So there's a lot of them out there. I switched from IntelliJ to VS Code some years ago, just because I like to mess with my get out of my comfort zone. So I was really comfortable, maybe a little unhappy with some certain things with IntelliJ, and I thought, all right, I keep seeing everybody talking about VS Code. I said, okay, time to switch. Get out of my comfort zone. So anyways, what I did was there's a lot of extensions in VS Code for coding assistants. Here's one, Codium. It's not super popular. It's got like 640 downloads or installations. Tab 9 is another one that's a little bit more popular, about almost 7 million. Amazon, they've been out with Code Whisper for a while. They have got 2 million, and I just got this a couple weeks ago when I made these slides. This is a relatively new one, so there's new ones popping up all the time. You can see it's only got about 20,000 installations. So if you look at the available extensions for code assistants, there's quite a few available in VS Code. And GitHub, the famous GitHub Copilot, 14 million downloads. And then Copilot's been out, I don't know, well over a year. I forget how long. Yeah. And then relatively after it came out, not too long ago, they came out with a chat feature, which is, everybody was asking for that. So that's got about 8 million downloads. But then you're getting things like this. This is a fork of VS Code, and it's called Cursor, and they say it's an AI-first code editor. I've been playing around a little bit. It's pretty nice, familiar territory, because it's in VS Code. But this one, you guys heard of this one? Devin? Yeah? March 12th, right? And it's not AI coding assistant, it's AI software engineer. Now, only a few people have their hands on it, but if you watch the demos, it's like, okay, all right, things are happening here. What are we going to do? It's quite amazing. It has like a browser. It's got a CLI. It's got the prompt window, and it's got the editor. It's kind of like 4 panels, I think, is the way they did it. But it's just running on its own, right? You just say, hey, do this, and it sets up a project, and it's got going. And it was like, wow, okay. They exploded. I mean, it just went wild when they announced it just a few weeks ago. Somebody, I probably won't do this anymore. If you're a developer, are you using some kind of code assistant now? How many are developers? How many are using code assistants? Okay. Now, don't feel bad. I mean, there's a lot of, I know a lot of companies are evaluating, the safety concerns and things like that. It's like, okay, 2 years, how long is it going to take to figure this out? So, okay, maybe I don't feel as bad to show you something. So let me show you just a little bit of this in action. So here's the chat part, and this was a chat I did some time ago, where I said, and I'm learning the tricks of using it. So there's tricks of using these things, and just techniques. So I said, using the currently open file as a reference, create a new class named shipping order view. So I'm creating a view in this application. This class contains 2 queries. One query selects by customer ID, and another query selects by shipping order, ordered at date. Both queries do paging. So it goes, okay, sure, here you go. And it dumped out this code. And there's a lot of boilerplate there. And I'm going, this is boring stuff. I don't want to write this stuff. All these annotations and, setting up classes, inheritance, and then the syntax of the SQL and everything. Done. I look through it, make sure everything's okay. Maybe, often it's not exactly what I want, but it's my fault. I wasn't specific enough to ask the AI to do something. In any case, it did it. So another thing I want to show you is that here's a form of prompting. So this is the code of one of these entities, all right? What I do at the end of the class, or somewhere in the class, I've defined, using Java records, the commands. So you can see create georder command, and then georder created event. So it's a relatively simple entity, but it's got these, these commands and events. So I put those in first, right? Then I go back, and there's the state. So you can see I got a record for the state. I like using a record because it's immutable, a few attributes. And then I got some methods in the state for handling like incoming commands. Like this, this is that event for method you might have noticed when I showed you the code example before. But a command comes in, this thing returns an event. All right? Another command comes in, I just overload the event for method. Doesn't have to be that way, but that's the way I like to do it. And it returns an event. And then events are the ones that trigger state changes. So you see an event comes in, and it returns a state, the altered state, from the event. That's it. So there's a couple missing, some code missing here. So I go to the, I use Vim and in VS Code. So anyways, I just went into insert mode, and you can see that this is the ghost code. I think hopefully you can see it. I didn't type. All I did was enter a couple of times, and if I hit tab, that's the code I wanted, right? So it's kind of working backwards through the code. So I need an event for the command. Now it didn't do it. It did. Sometimes it works great. There it goes. I had to give it a little push. So there's the method for the command to create the event. But there's a little bit more boilerplate up here, some annotations for some things. I won't bore you with the detail, but it knows. It's like, oh yeah, I think you need an event handler for this event. Now it's mimicking my style. It's like I got these log messages that I wrote, and it mimicked, just kind of took that as a pattern to give me another log message. But the main thing is it's doing the code that I'm needed. So the last one is up here. So yeah, this is a back order, which is right. Let me scroll up a little bit. Oops. There we go. Relief, it did it. So that's a little bit more code, right? It's following the pattern. I've got this pattern of code you can see up above here, and it's just kind of mimicking it. So that's why I was saying AIs love these patterns, right? So anyways, it's like often when I'm using this thing, it's like you're in my head. You're reading my mind as I'm working on the code. So the last part, this is where I go, I'm pushing far. So the general idea is, I call it, and I'm sure this won't be the name going forward, but this is what's going through my head, is test-driven prompt programming. That's the general idea. So imagine that the source code is no longer what we consider to be source code today. It's the prompts that are the source code. This is where I'm pushing further than, I think we're kind of maybe in a little bit, think of this as what we talked about this morning is path forward is path A. What I'm proposing here is path B. Path A was, well, yeah, Java and all these languages will be around for a long time. We'll be writing that kind of code. There's a non-zero probability that this is a path going forward, that we will not be looking at Java, Python, JavaScript, TypeScript, whatever, anymore. And it may not be that far out. So what I'm pushing into here is consider what we're not doing right now. What we're doing now is we're prompting and we're generating the source code, we're throwing away the prompts. What I'm saying is that flip it. Your prompts are the new source code. This is what you check in, right? So just something to consider. Don't get mad at me. But this is going to take skill. And because what we're developing is human and machine readable prompts. And I think maybe a potential technique is that there's a style to these prompts that we're not quite clear yet, but maybe it's something like it's very result-oriented type of prompts. And maybe it's very test-oriented types of prompts. So it's like, I expect the behavior of the system to be like this, where when this comes in, this comes out. And for a test, for example, if you do this, when this happens, then this should be the result, that type of thing. So the AI could take that, write the code in whatever language, I don't care, that it wants to write in, writes the tests in whatever language, again, I don't care. What I care about is, do my tests that I built together with the AI pass? Does it behave the way I want it to behave? If it doesn't do that, then I go back to the prompt and I tweak it. So the development process is pretty much like what we do now. It's iterative development. So think about this. And I think Brian mentioned this morning, is the code is very precise. Human language is very imprecise. Like my wife and daughter, they drive me crazy. They say, the thing. The thing. And I was like, what the hell are you talking about? And they get all mad at me. It's like, but it's very ambiguous. What I'm saying is that you're iteratively developing sufficiently unambiguous prompts that create the software system that you're asking for. And what I'm also saying is that don't expect the AI to know everything that you want. So our job is to describe systems in sufficient detail, sufficiently unambiguous detail, so that the system does what we're getting paid to do. That it has the behavior and the capabilities of what we're doing. I don't think that's too bad. That's kind of fun. You're still writing, you're still developing something. The fun for me is like design, like I said, those design diagrams, the flows of the components within the system. I really like that. I like doing that. I love writing code, but there's also the tedium to it. There's a lot of tedious boilerplate that we're always trying to get rid of. This really takes things to a new level. So, like I say, I've been thinking about this for a while. I haven't done anything. If I had come up with this system that does test-driven prompt programming, I wouldn't be here. I'd be on my jet, zooming around the world somewhere, enjoying Europe. Not, I like talking at conferences, but I could definitely get into having enough money to have a life of leisure. So, but anyways, so I went to ChatGPT and I talked to it. I always think of it as like warming up the AI. So I said, hey, I got this idea about test-driven prompt programming. And we went back and forth for a while when I explained what it was. So I'm warming up the context, right? Then I said, 'cause what I've been dreading was actually writing the prompt. I felt like, okay, there's going to be a lot of detail in the prompt. So I said, hey, all right, now that we've discussed this, I said, please provide an example test-driven prompt, such as the process of a customer adding an item to an order, such as a fast food order. And it goes, ChatGPT goes, oh, hey, here's an example. And it goes, boom, it dumps out this document for me. It says prompt, add item to order, user story. And that's where okay, wow, user story. As a customer, I want to add an item to my fast food order so that my customer may I can customize my meal according to my preferences. Input specifications. Boom, what fields are expected in. Expected behavior. Boom. Now, the last one, like system recalculates the total price. So, okay, that's ambiguous, right? That price calculation could be very detailed. We probably have to go into that some more. But that's the iterative development thing. But this is a starting point, right? And then output specifications, constraints, and then finally, test cases. So it's like, wow. It was like this really interesting moment. It's like, okay, not only can I use the AI to write the code, but I can use the AI to write to the prompts, help me write the prompts, detail them out. I give it a bit of information, it fleshes it out. Now we can tweak it. We got something really of substance to tweak, and we keep working on it. So that's where I think, maybe thinking of systems at this scale with some of these really interesting behavioral characteristics based on patterns of computation that are similar to the way the approach that seems to be winning across the planet, our brains, the way our brains work, the way AI works, having these reusable patterns, and then these styles of writing code that perhaps we're not going to care about in the not too distant future. So I'm imagining these systems of tightly focused, loosely coupled components that produce surprisingly powerful processing behaviors. So I don't know. We'll see what the future brings. If anything, it's going to be interesting. So we covered Micromine services. We looked at the AI coding assistants. I would go back and demand that you want to use AI coding assist. It's not that expensive. I know there's concern about security risks and things like that, but they're incredibly powerful, and it's moving very quickly. And I hope I get you to leave with a non-zero probability that things could be seriously different than what we might be thinking about, that maybe we have a bit of tunnel vision or a bit of denial. I know I'm going through all kinds of weird emotions right now with this whole thing, but I also like to see, okay, where do I fit in this future? You got to stay ahead of that. So I want to leave you with vesperance is kind of a melancholy word, a little bit of a downer. I wanted to come up with a new word, but I couldn't find one. I couldn't make one. But one word that I'm not that familiar with is called innovera, which is used, and it has this. It has a definition, but I want to change the definition a little bit. it's this weird and kind of cool experience you get when you're using AIs when it does something that surprises you. Like when it gave me that prompt document back, and I go, wow, you just took a bunch of tedious work that I didn't want to do and made it easy. And I get this, and when it writes some code over and over again, and it dumps out a bunch of code and go, that's what I wanted. Thank you very much. I mean, there's a frustration when it doesn't do it, but you get this wonderful feeling every once in a while when you're using these tools. So to wrap up, I'll just say it. AI will not replace you. We said this in the panel this morning a little bit differently, but AI is not going to replace you. People using AI will. So you got to keep ahead. This one's the most important, though. I use this in all my talks. I love this quote by Alvin Toffler. The illiterate of the 21st century have not been those who cannot read and write, but those who cannot learn, unlearn, and relearn. I can tell you from my own personal experience, getting into this form of programming that I showed you earlier, I had to do a lot of unlearning of decades-old habits of programming to kind of push myself into this new way. So here's the QR code for the slides. What I've been talking about was inspired by something from my company at Lightbend called Calyx. The QR code's there. It's a platform as a service, but you can try it out free. The other thing, though, I've been experimenting with this. I'm making an offer to anybody here. If you want to talk some more about this, like one-on-one, or your team or whatever, and you'd like to set up a time to do it, reach out to me. I'd be happy to do it. It's a win-win. I'm going to learn a lot. I'll probably learn more from you than you'll learn from me. But nobody's taken me up. I've done this for the last few conferences. Contact me on Twitter. LinkedIn's even better. Twitter, but LinkedIn. We'll set up a time. I'm on the East Coast in the U.S. If I'm not traveling, I'm over here a lot. But I'd be, do it. Let's talk some more. I'd love to show you some more of this stuff or hear what you're doing. And these, it's like a hallway chat, but doing it virtually. So, anyways, thank you very much. And if you have any questions, I'm open to questions. Thanks. Any questions? Come on, there got to be some questions. I pushed you guys into some really weird territory in this talk. Thank you for sticking with me on this. But yes, oh yeah. So the question is, it generates some code, but can it refactor it, right? Yeah. Yeah. Yeah, it can. It definitely can do that. It's really good at like looking at existing code, and you can say, fix it or explain it. And and another thing that was mentioned this morning, like COBOL code to be around for a long time. No, it's not. You know what's happening already? There's AIs that are reading COBOL and transforming it to another programming language. So legacy code isn't, isn't safe. And this horrible COBOL code that's been around for decades that everybody's afraid to touch and refactor, and rewrite into another language. This is what AIs are capable of today. Like this one here? The diagrams, Blender. Yeah, the graph, Blender. Blender is a open source 3D tool. It's really very powerful. Blender.org. I use it a lot. The video I did was done with Blender, which, by the way, Blender has an API in Python, and I've wanted to use it for a long time, and I wanted to do an animation with Blender for a long time because I've done stills for a long time in my presentations. I used ChatGPT to help me write the Blender to create that movie. Right? It was like 2 days of something that I would not have a clue how to do it. It knew the API of Blender intimately, but it was like function by function. We wrote each part, and we built out the movie. It was marvelous. It was this was like early last year, and I was like, okay, this is pretty significant stuff that's going on here. Yes, sir.
So you said that one of the paths might be source code as prompts.
Yeah.
But currently, generative AI doesn't usually respond the exact same thing to the exact same prompt. So wouldn't that be a risk to have different application outcomes from the same prompt?
So the question is, it's random, right? You put the same prompt in, you get a different answer each time, right? It might not be completely different, but it can be, like for code, it could be different, right? Yeah, and that's a good point. So that's adjustable in some of the APIs for AIs. But I think the other part, though, is that this is the test-driven part. That the idea is that you have sufficiently unambiguous tests that are generated, and if the generated code doesn't pass those tests, then the AI using agents and things like that go, oh, I got to fix that. And we saw that in like the Devin demo. It saw an error, and it looked at it and goes, oh, I know how to fix that, and goes to fix it. That type of thing. So
you regenerate until the tests are
exactly. So the tests are extremely important, which they should be, right? It's capturing vulnerabilities and security, it's capturing vulnerabilities and incorrect processing flows, those types of things. Yes, sir. Sorry, real quick.
Yeah, there's been a lot of issues addressed also in the panel from this morning with AI, like introducing security issues in the code that gets generated. And there's also like a lot of things that cannot cover in tests, like non-functional requirements, like how do you test a huge data set and the performance of the system and so on and so on. So how much do you estimate that we need? Like where do you see the point that this becomes actually feasible to say we will get working prompts? Like the indeterministic part is just one of the issues that I see with currently using this approach of software development. But do you foresee any future? Like is it in the near future, like 3 to 5 years, or is it a long term?
It's hard to predict how far out this can happen, right? We're seeing bits and pieces of it now. But to your more fundamental question, like security vulnerabilities or non-functional requirements and those types of things, I'm starting to look at it as like, okay, think of it as there's this team that we've hired to build the application for us. And we have a level of trust in this team, but there's also some responsibility on us, or somebody, to certify that the application that we've entrusted with this team to develop is developed correctly, taking into consideration, all those things that you mentioned, because they're very valid, right? Like performance and security and all those types of things. But it's like I'm starting to envision the AI is just another development resource, another development team, right? And we treat it in the same way. So like a performance test, run a performance test. Have the AI prove it, that the system, like how much is it going to cost to run this thing? Tell me. So who knows when? Things are moving so fast. I mean, like right now, everybody's kind of on pins and needles waiting for OpenAI to come out with GPT 4.5 or GPT 5. Because Claude, and even now, I think I just saw today, even Grok, from XAI, came out with a new version that's scoring very well. So GPT 4 is falling a bit behind. Claude 3 is ahead. And everybody's anticipating that there's going to be a big release probably this summer from OpenAI. And who knows what kind of capabilities we're going to get with that.